Okay, so this lesson is about solving absolute value inequalities. These are one dimension. This is just like solving the equations. I'm going to start with number 2. Is there anything in front of the absolute value bars? No, there's not. Is there anything right after it? Again, no, there's not. So there's nothing to move. The bars are by themselves. If that's the case, then we're going to jump into our 2 scenarios. In scenario 1, p plus 4, remember the bars go away, less than or equal to 8. It basically looks the same. But in scenario 2, p plus 4, now what we're going to do in scenario 2, let me clean this up. That plus sign looks a little weird to me. But in scenario 2, the arrow is going to go the opposite direction. And this time we're still going to say negative 8. So you got a positive scenario and a negative scenario. Now our goal is to get p by itself. We're going to do the opposite of everything we see. I see plus 4, so we'll do minus 4 and minus 4. Turns out in both scenarios you're doing the same steps, just with a different outcome. So if I took away 4 here, they would cancel, leaving me just p less than or equal to 8 minus 4 is 4. So p less than or equal to 4. Now if we come over here, the 4's still cancel. There's p greater than or equal to negative 8 and negative 4 actually makes negative 12. So that's what I mean, you have different outcomes. And we're not going to check these to see if they work. Instead, we're going to draw a little picture of both of them. We're going to say p, does it have a line underneath it? If it does have a line under the arrow, we're going to say that is a colored in dot. That's nothing new. We've seen that before. If there's no line, we're going to say that's an open circle, and we have a line underneath here. So we're going to go ahead and use the closed dot. We're going to go to 4. Create that closed dot. We're going to look at which way the arrow is pointing. It's pointing to the left. So that means we need to shade to the left. And then we look at this one. It says p is greater than or equal to. P is the bullies picking on negative 12. And then negative 12, it gets a closed dot. Since the arrow goes to the right, we're going to shade to the right. And you keep shading until the shading connects, it turns out. All the solutions, if I took any number in this shading, negative 10, let's say, and plugged it in, this would be a true statement when I calculated it. Let's try another example here. Absolute value inequalities. All right, is there anything, we'll do number 5, is there anything in front of the bars? No. Is there anything after the bars? Yes, there is, so we don't like that. We need to move it. I'm going to write him down here so we have some space to work. All right, so we're going to move that 5. We're going to do the opposite of what we see. That means the absolute value of x, the 5's cancel, greater than or equal to 11 minus 5 is 6. Now there's nothing in front of the bars, nothing after the bars. That means we have our 2 scenarios. In scenario 1, x is going to be greater than or equal to 6. But in scenario 2, x is going to be less than or equal to negative 6. So we change the arrow and we change the sign. Now we got to get x by itself. It looks like we've done that already. So we're going to call that the solutions. Let's go find where x is 6. It's got a line under the arrow, so we're going to close that dot, and it points to the right. So all our shading this time is this way. Then we're going to go find negative 6 on the number line, close dot, because there's a line under the arrow, and it's pointing to the left. So all the solutions for that one go the opposite direction. So that means I could grab any of these numbers, plug it in, it would work in this inequality, or I could grab the numbers over here, plug it in, and it would work, but none of the numbers in the middle are solutions. We can't choose any of those values. Let's find an even harder problem still. All right, we're going to try, let's do number 10, then we'll do number 11. So in number 10, what's happening is there's nothing in front of the bars, but there is something after the bars. So that means we need to do plus 3 and then plus 3 right here. Now, the x minus 4 inside the absolute value bars will come down. The -3 and +3 cancel. There's our arrow pointing left. That means less than, and 5 plus 3 is 8. So that's what we were left with. Now there's nothing in front. There's nothing after the bars. The bars are by themselves. At that point, we want to do two scenarios. So we're going to free them from the bars. X minus 4 is less than 8, or we got a scenario of x minus 4 is greater than 8. All right, so we flipped it, and we got to remember to change the sign on the second one. Now we're going to solve, doing the opposite of what we see. The opposite of -4 is +4, so we'll do it there. Remember, it's the same in both scenarios, just with different outcomes. So the 4's cancel, x comes down, less than 8 plus 4 is 12. Over here, the 4's cancel, the x comes down, greater than -8 plus 4 is -4. So here's what we've got a graph here. I'm going to uncover our graph, see if I can erase some of this. All right, x is at 12, but it doesn't have a line, so it's going to be an open dot. And the arrow's pointing left, so we want to shade to the left of 12, anything less than 12. This one, no line, it's at -4. We're going to put a circle around it, open circle. The arrow points to the right, so here we shade to the right. All the solutions live in this shading, but you cannot choose -4 as a solution because that's an open circle. So -4, if you plugged it in right there, would not give you a true statement. Same with 12. You're not allowed to plug 12 in, but you can plug anything else in between those values. Now, I want to point out, I don't think, unless I can find a situation that requires us to do this, yeah, maybe -15. Let's try that one. I think that'll do it. If you ever divide by a negative number, the arrow's going to flip. And I think -15 is going to do that for us. Anything in front of the bars? No. Anything after the bars? No. That means jump straight into your two scenarios. -8a minus 3 is greater than 11. So nothing changes. You just drop the bars. But in scenario 2, -8a minus 3 less than -11. Okay, so we're going to try to get a by itself. We're going to do the opposite. Remember, we're doing PEMDAS backwards, so we got to start with the add subtract. The opposite of -3 is +3. Do the same to the other side of the arrow, and in fact, we're doing the same thing in this scenario as well, right? Same steps, different outcome. From left to right, the -8a comes down. The 3's cancel, and that is greater than 14. So now we're going to divide by -8. And here's that new thing I was telling you about. If you divide by a negative number, your arrow is going to change directions. The -8's cancel, so a is still there. Now, both of these numbers are even, so they reduce by 2. 14 divided by 2 is 7, and -8 divided by 2 is 4. And that number is negative because of the negative at the bottom here. So a is less than, a is getting picked on. So these guys think they're the bully this time, picking on a. A is less than -7/4. Over here, the -8a comes down. The 3's cancel. Less than -11 plus 3 is -8. Now we divide by -8. Oop, there's that thing again. Dividing by a negative causes the arrow to switch directions. So now a is greater than, a is now the bully. Is going to get them back. Notice a is doing the pointing. Negative and negative gives me positive. 8 divided by 8 is 1. So here's our solutions. We got to now graph it. 7 divided by 4 is just a little less than 2 because 8 divided by 4 is 2, right? So let's uncover our graph here. And if it's a little less than 2, it might be, and it's -2, by the way. Maybe right about there, but we don't want a closed dot. I messed that up. We want an open dot. So whatever 7 divided by 4 is, probably negative what? 1.75. We can put it in Desmos and figure it out. Not including that number, you can't plug it in because it wouldn't work. It's an open circle. And then we're going to go over to 1. We're going to give it an open circle. Now look which way the arrows go. For this guy, he's pointed to the left, so the solutions live over there. But for this guy, he's pointed to the right, so the solutions go over there. So the solving similar is the equations. Instead of checking, we're just going to shade on the graph.